Hey everyone, welcome back. In the last video, we have seen how to build customer agent, orders agent, and product agent. We have defined one LangGraph structure and we have used same LangGraph structure as customer orders and product agent just by changing our inputs. So in this video, let's try to understand about all the other nodes that we have in our agentic workflow. So now, in the last class, we have started with this example, right? Here in this example, there is a user question: give me list of customers from Sao Paulo state that made at least one payment through credit card. And this question is routed to two different agents: customer agent and orders agent. So now this is how the output from customer agent looks like, and this is the output of orders agent. So now what we do is, for every column that we have in both of these agents, we go into our knowledge base, we fetch the description of these columns. So what do you mean by that? For example, let's say the output of customer agent looks like table equal to customer, column is customer ID. This column gives list of customers. So now what we do is we take this column to the knowledge base. If you go to knowledge base, so we are storing our knowledge base into this variable, which is loaded underscore dictionary. So if you just look at the customer table, this is the description of customer state or other columns, right? For example, if you consider customer state, the two-level abbreviation of Brazilian state where the customer is located. So this has slightly different description, right? For each of the columns that are selected by both of these agents, we try to extract the column descriptions from the knowledge base. And with all this information, along with the user information, what do you mean by user information? Is just the user question, right? So with all this information, we send this information to the filter check. What filter check does is it will check if we have to apply any string filters to any of the columns. So what do you mean by a string filter, right? Here, if you see this question, you have lots of filters, right? I want to get the list of customers from Sao Paulo state, right? Sao Paulo can be one of the filter. And I want only the list of customers that did payment only through credit card, right? This can be one more filter. These are string filters. There is one more integer filter as well. I'm also asking for customers that made at least one payment through credit card, right? That's greater than or equal to one is also a filter, but we don't consider that. We just care about a string filter, right? There are two string filters over here on top of customer state and on top of payment type. That's what is done by our filter check. So now let's quickly look at our Visual Studio Code, how it is defined. If you go to the main function or the main IPYNB file, so we have defined our filter check node, right? So we are giving all the information to the specific chain called as chain filter extractor. It will be inside our customer helper. Where is the chain filter extractor? Yes, there's a chain filter extractor. It is also a simple lang chain. So now if you carefully see, what it is saying is, if you just look at the output format, if it thinks like there is no filter is needed, the output will look something like this. It's just no inside a list. If it thinks like, no, we have to filter few columns, the output will look something like this, right? So in the first index, we say like, yes, output, I mean to say filter is needed. It is in the 0th index, right? So from the first index onwards, we have on top of which columns we need filters. Here we are saying like customers on customer city, you need to have some filter, something like this, right? For example, if you need to have multiple filters, right? You can just represent something like this. In the 0th index, yes, filter is needed. From the first index onwards, we need to give on top of which columns filters are needed. Right here, I'm saying from order payments table, order type is, I'm sorry, payment type column. These are the potential values, right? This is how I give as an example to the LLM. So it has to generate the recommendation in this format, right? So now soon after we give all the information to the filter check, right? So it gives output something like this. So for this user question, Yes, we require filters, right? That's the reason the output is yes. We require filters on top of two columns. First on customer state column and another one on payment type column, right? But if you carefully see here, the customer state here, it is mentioned as Sao Paulo. So now because we are giving column description from our knowledge base, and what is there in our knowledge base? In our knowledge base, it is very clear that customer state is two-letter abbreviation of Brazilian state where the customer is located. So it knows that in actual representation of the column, the states are not represented via their direct names. Rather, they are represented as their abbreviations, right? So that's how it thinks like, okay, for Sao Paulo state, the abbreviation can be something like SA or SP, whatever it thinks, right? So it gives recommendation something like this. Yes, customer table, in customer state column, use SA as a filter to Sao Paulo state. In order payments table, in payment underscore type column, right? So you need to have your filter as credit card. So now this is what is the output of filter check. So now this output, you need to send it to a new node, which is called as fuzzy agent, right? So let's go back to our main file. Yes. So here we have defined our fuzz match node. So in this fuzz match node, we are just extracting the output of my filter check, which is under filter extractor. So now I'm just giving that filter extractor to this function, which is called as call underscore match. Let's quickly see what is there within this. It is there within fuzzy underscore wuzzy.py. So this is the call underscore match. So now what call underscore match does is, let's go back to our Miro board. So I'm telling that if you just consider this in order payments table in payment underscore type, right? My value is credit card, right? This is how I give as an input to fuzzy agent. Sometimes what might happen is in my payment type table, this value might not be represented exactly as credit card, right? It can be represented in any number of ways, right? What does that mean? For example, let's say credit card can be represented as credit underscore card, right? It is possible. But here, what is there in the user question? In the user question, it is mentioned as just credit card. That's all, right? There can be such kind of differences. But while writing SQL query, we need to find the exact match. So that's the reason what we do is we try to find out the distinct values on top of this column in this table. We just simply say select distinct payment type from order underscore payments. Right? We collect all the distinct values in the payment type column in this table. We extract that into a list. Right? These are the unique values from payment underscore type column. So now what we do, we take this credit card value and do some kind of simple fuzzy matching. What do you mean by fuzzy matching? There are in natural language processing, we call something like fuzzy fuzzy features. So we have something like token sort ratio, token set ratio, fuzz ratio, or something like that. The essence of these metrics are given any two strings, S1 and S2, they try to match the two strings and give some score on how similar both of these strings are. So that's what we do in fuzzy wuzzy matching, right? That's what we exactly do over here. Let me go back to Visual Studio Code. So now this is where in the get values, we're just extracting the distinct values from the column of the table. So now in my get best fuzzy match, I'm using something called as token set ratio to find out the best match for my input to all the values in my list. And what are these values in my list? These are nothing but my distinct values in my column. So I'll match my credit card with all the distinct values that I extracted from this function and do something called as token set ratio to get the nearest match of credit card. So now I extract that nearest match, right? I extract that nearest match. So the output of my fuzzy agent will look something like this. So I do the same thing. I do the same thing for all the output that is given by our filter check. So filter check here has given two list of lists. right? Sorry, it has given a single list, but within that, there are two sublists. So for each of the sublists, we follow the same process. Once we follow the same process, our output from the fuzzy agent will look something like this. In customer table, in customer underscore state column, filter as SA. In order payments table, in order payment underscore type column, you filter with the name credit underscore card because this is how it is represented in payment underscore type, right? So now with all this, right, with all this, so this is the output of the fuzzy agent. With the output of the fuzzy agent, with the output from each of these agents, customer agent and order agent, along with the user portion, right, we give all these details to the query generator to generate a SQL query, right? So that's what we do over here. We go to main.ipynb. This is the node that we are defining for query generation. So in this node, we use something called as chain underscore query extractor. It is there in our customer underscore helper, right? So if you see, it is taking three things as input. First, the applicable filters, which is the output of my fuzzy agent. The list of columns, which is nothing but my output of my both of my agents, right? And this is the user question. So based on this, I'm prompting my LLM along with some basic conditions on just telling like how it should think while generating a SQL query. You can just go through this prompt later. I'm asking it to generate a SQL query. So now once my SQL generator agent generates my SQL query, that SQL query is sent into query validator agent. What this agent will do is, uh, let's go to our customer helper again. So it will take user question, the output from both of our agents, and applicable filters, which is the output of our fuzzy agent. It will also take SQL query, which is the output of our query generator agent. It will see if there is any issue with the query generated by the SQL generator agent. If there is no issue with the query generator, it will output the same query. If it thinks like the query has to change something, there is some issue with the query, it will think and change the query and it will give the updated query as the output. This is what is done by our query validator node or agent, right? So once we get the output from the query validator, we end our workflow. This is how we build our agentic workflow, right? So now we have seen how to initialize all these nodes, right? First match node, filter check node, query generation node, and query validation node. So now let's see how do we connect these nodes here, right? We have already seen till this point, right? Once we add conditional edges from our router node to all these three nodes dynamically, we will need to add an edge from customer to filter check, orders to filter check, and product to filter check. So now from filter check, we again need to route, right? We again need to route to different paths, right? If you slightly go here. So in the filter check, if the output is no, right? If the output is no, we don't need to get into fuzzy agent. We can directly go to query generator to generate the query, right? We need to go to fuzzy agent only if filter check tells that, yes, there is a need for us to do some kind of string filtering. That's what we have mentioned over here. In the conditional edge from the filter check, based on this condition, I want to route my path from my filter check to different nodes, right? Let's quickly see what is there in the filter underscore condition node. In the filter underscore condition, I say like if length of my filter extractor is one, when it will be one, it will be one only when the output of the filter check is something like this. Only if the output is no, only then the output of my filter extractor, the length of my filter extractor will be one, right? So if it is one, I'm returning no. If it is greater than one, which means that there is a requirement of filter, then I return yes. So now with this understanding, let's go down. Yes. So now if my filter condition says no, directly route to my query generator. If my filter condition says yes, go to my first filter, right? So now if I go to my first filter, I need to add an edge from first filter again back to query generator. right? So from query generator, I need to add an edge from query validation. And from query validation, I'm just ending the workflow. So now at the end, I simply say graph underscore main equal to builder underscore final dot compile. So this is how we build a LangGraph application, right? So now if you simply print graph underscore main, this is how your LangGraph looks like, right? You start, you have a router. Because all these three are conditional edges, you get dotted lines. Again, from filter check, you have conditional edges. That's the reason you will have dotted lines, right? And the output goes to query generator, then to query validation, and then we are ending our workflow. So now this is how we build our text to SQL system. I think pretty much that's it for this video. In the next video, what we'll do is we will execute this workflow. I'll show you some examples. We'll just send those examples into this agentic workflow and let's see how the output looks like. Once we see that, we'll also see some of the best practices to follow in a text to SQL architecture. Great. See you in next video. Bye.